Hello and welcome to SudoKanard. Here is a Thermo Sudoku created by some Cappleman-Lynes for the United Kingdom Sudoku Championship of 2022. It was worth 82 points, which was the second highest pointer in the round. And I don't think the puzzle was that difficult, but I broke it several times before managing to just, find the right solution. So maybe the difficulty is just not messing up, which is a real difficulty for me at least. So I'll just remind quickly the rules. Whenever you have such a thermometer, then the digits along the thermometer must increase in the strength sense starting from the bottom. And that's it. So the thermometers are not that long, and there are very few given digits, and believe it or not, those given digits are not necessary for the puzzle to have a unique solution. But I didn't try to solve it without those three given digits. So I think it must be too much of a struggle if you remove them. So where do we start? We have two thermometers that are near the given digits, so we must just study the interactions. I begin with pencil marking the smallest possible values for those cells. So that's a minimum of 1, minimum of 2. This can't be a 3 because of this, so minimum of 4. Then this can't be 5, minimum of 6, and minimum of 7 here. So now I complete with all the other values available. So minimum of 7, so 7, 8, or 9. Minimum 6, less than that. Can't be a 7, could be 8. This can't be a 5, must be less than that, so 5, so 4, 6, or 7. This must be less than that, and there are too many options. I won't pencil mark them. But I do the same here. Minimum of 1, so I remove the pencil marks, I think. So minimum of 1, minimum of 2, minimum of 4 again. And the logic is very symmetrical in here. Minimum of 6, minimum of 7. So 7, 8, or 9, 6 or 8, 5, 6 or 7. But then you see that there is a 6, 8 pair in here. So 6 can't be in any of those cells. And I remove the pencil marks here for the same reason. And we get a 5, 7 pair in here, and actually those digits must be from 1, 2, and 9. So that's some solid pencil marking here. And now let's have a look at this thermo and this thermo. So the minimum is 1, 2, 3, 4. So that's a minimum of 4, and therefore that's a minimum of 5. And the same happens here. So on this row, the only places for 1, 2, and 3 are those 3 cells. And the remaining cells must be from 4, 5, 7, and 9. So 4 is in here or here, and so 9 is here or here. And this now is interesting, because we see that this will never be a 2. If I try to put a 2 here, then by the Thermo rule, I must put a 1 here, and there's no candidate for this. So, knowing that this can't be a 2, nor a 3, the minimum value now becomes 4, and this is never a 4. So that's a 7, and that's 8, and that's 9, and that's 4, and that's 6. And this 9 is not here, so 9 is here, and this is now 8. Now, because of this 4, this must be from 2, 3, and this must be from 1 and 2, and we get a 1, 2 pair in the column, and this is a 3. So 1, 2, 3, 4 are in here, and we must have digits smaller than 7, so there must be 5 and 6. And 8 and 9 complete the column. So that's a quite intricate start, but very well put together. as you would expect from Sam. 9 is not in here, so it must be somewhere along this. And this digit here must be somewhere in there, which is not saying that much. And 4 here wouldn't work, because 4 here would need 1, 2, and 3, and that would clash. So that's not 4, that's not 5, and this is 4. And knowing that this is 4, the beginning of the Thermo is automatically completed. And this can only be a 2, and that's 1, that's 2. That's 2 as well, and that's a 3. So that resolves a lot. 8 is not in here, must be here. And actually I think this can only be a 6, and that's correct. So we need, oh, 9 is not here, so 9 is here on this row. Here we need 1, 5, 7, and 8. So that's a 1. And the candidates here are 5, 7, 8. On the other end, we get a 2 and a 4. And here the digits are from 1, 5, 6, 7. But 1 will never be in this position in the Thermo. And because this is smaller than that, this will never be a 7, and this has to be a 7. And that's a 5. So going down, that's a minimum of 1, minimum of 2, and this has a maximum of 5, so 2, 4, 5, can't be 3, and this is 1, 2, or 4, and I don't think I can do better at this point with this Thermo. Now this 8 here is in one of 2 places. And what about this cell? Can't be 1 or 2, so it has to be 4 or 8. 1 and 2 are somewhere in here. So let's look at the interactions. This 9 says that this has a maximum of 8, so this has a maximum of 7, except that 7 is not available, so maximum of 6. Here maximum of 5, 4, 3, except that 3 is not available, so maximum of 2. This is 1 or 2. This can't be 3, so 2 or 4. 3, 4, 5. 4, 5, 6, but 5 is not available. And at least 5, so 5, 7, or 8. I'm not seeing anything more precise about this. This can't be a 5 here. So 5 must be in one of 3 cells here, so this can't be a 5, and this can't be a 4 anymore, that's a 2, and that's a 1. And now 2 in this box can only be here. And the column is completed with a 4, 8 there, and this is 4 or 9. So 5 is in here. Not seeing anything else. Let's have a look at this Thermo, I think. So first, this will never be a 1, so 1 is in here. Could this be 6? 6. Because I know there must be a 6. It can't be a 4. So this is 6 or 9, but 6 looks very restricted. If I try to put a 6 in here, then this will be at most 5, 4, but actually, no, that's not the right way to look. This is at least 2, 3, 5, 7. So let's do this. This is at least 2, 3, 5 because of those digits, 7 because of the 6. So this can only be a 9 because of this 8. And we get here 8, 4, 8 here. That's not 8. 9 and 4 and 3 here. some solid progress. Here we get 1/6 pair. So I say minimum. So minimum, and actually it can only be a 7. So this is 5 or 6. This is 3 or 4, but not 5. And only 2 because 3 is not available. No 2s in here. And actually I get a 2 somewhere in here in this box. What can this be? 1, 2, 3 is available, 6 is available, and I think that's it. I need a 1 somewhere on this row. So that's a 4, that's a 5, that's a 6. And this cell, 1, 2, 3, 4, 5, that can only be an 8. In this column, I still need 3, 4, and 5. So that's a 5. That's 3 or 4. That's 3 or 4. And I get a 3, 4 pair. So that's a 6 and that's a 5. Here I need 1, 2, and 3. So 3 is here, 2 is here, 1 is here. 5 and 1 are resolved. That's 4, that's a 2. Here I need 1 and 9. That's correct. 7, 8, and the last digit is a 6. Now should I look? This row needs 6, 7, and 8, so that's 7 or 8. Here I get a 6, 7, 8 triple. I need 3, 4, 9 in here. I can remove this 3. Note that 7 is in one of those places, so that's not a 7. This column still needs 6, 7, and 9. So there's still some work to do. But this row still needs 1, 6, and 9, and because of this, that has to be a 6. So that's not a 6, and 6 in this column must be here. Alright, it resolves a few digits. That's not a 4. Here I get this and that. Now this can only be a 1. This can only be a 7. So that's 9, 7 in here, and 9 here, and 8 there. So it needed some work. But it was all standard deduction, and there was variety, there was diversity in the deductions, which makes it a really, really good puzzle. And that's exactly what I was saying about numbered rooms, but it's really the same kind of puzzle. I'm a bit surprised that the number of points is that different between the two puzzles. Perhaps this one needed to dig a little more. Well, I just wish I had been able to solve it without mistakes during the round, but that is my issue, this is not yours. Thanks for watching this video, and see you soon on SudoKanard.